Hello and welcome to the Bearded Mathman's YouTube channel. In this video, what we're going to be talking about are reciprocal functions. We're going to see why and how reciprocal functions work, where they come from, why they're useful. So we're going to learn that the reciprocal of sine is cosecant, reciprocal of cosine is secant, reciprocal of tangent is cotangent. So let's get to it, shall we? Now, in order for you to better remember how these work, I think it's going to be important that you see why they might be valuable, what kind of problem they solve for us. And so I'm going to introduce two ideas before we get into it. And those two ideas will help you better understand what reciprocal functions are and help you to understand why they're useful. And especially when you see why they're useful, helps you remember. So if I asked you to solve these two equations, like you're going to solve this one for c or this one for x, well, they're a little tricky. And so this would be the right way to do it. You multiply both sides by c, and then you divide both sides by the sine of 32. Whereas here on the right, you're going to multiply both sides by x minus 2, multiply by the reciprocal, and add 2, and then you're going to get 46 over 3. You could make that as a mixed number, but whatever. The point is that while these aren't that tricky, there are some common mistakes that happen so often that these problems like these where the denominator is the thing that is unknown and needs to be solved for, these things are missed more often than not. So let's talk about two common mistakes. First common mistake is people will say, oh, we need to solve for c, and you get c by itself, and we have division. The opposite of division is multiplication, and they write this. Now that's of course wrong, because what's actually right is you would have 17.2 squared over here, and on the left you would have 17.2 times the sine of 32. Either way, c is still in the denominator. It's nowhere closer to being solved. Now, another common mistake that people make is they say, oh, well, I need to solve for x. I got to get rid of the 5, so I'm really supposed to multiply by the reciprocal. And so they write this right here, but that's, of course, totally wrong as well. Because what would end up happening, if you multiply both sides by 1/5, you'd end up with this. Once again, nowhere closer to being done solving for x. And so the number one idea I want you to appreciate before we get into these reciprocal functions is the idea that if you're solving an equation and the unknown is in the denominator, it's tricky, right? Now, let's get to the second idea. If I asked you to solve this, what would be your first step? Well, hopefully you would say you would square both sides, and that's correct. And so that brings us to our second idea, and that is that if you have an equation, you can raise both sides of that equation to an exponent. Now here, it makes sense to do squared because squared and square root, those resolve one another. But you could raise to any power. You could raise both sides to the power of 17 or -1, which is what we're going to do right here. See, if we are trying to solve for x, if we raise to the power of -1, then that's division, and division is multiplication by the reciprocal, so everything is flipped over. We take the reciprocal. That's what the exponent of -1 does. Now, this is a much simpler equation to solve than what we started with. Same thing for the equation where we're trying to solve for c, which would end up being the hypotenuse of a right triangle. If we did the reciprocal, then c ends up being in the numerator, and that's a whole lot simpler to solve for. All right, so trigonometric functions, the ones we know and love, like sine, is opposite over hypotenuse. However, if you're trying to solve for hypotenuse, it might be nice if we could just start off with a reciprocal function. And that's what we have here. We have the reciprocal of sine, and that would be the reciprocal of opposite over hypotenuse. Because if you have something that's true like this function equation right here, you can raise both sides to the power of -1, which makes reciprocals. Now, the power of -1 is a really tricky thing. I've got 3 examples right here at the bottom of the screen. All look very, very similar, and they all have entirely different meanings. First one, sine of theta, the whole thing to the power of -1, that's a reciprocal. That's 1 over the sine of theta. Whereas sine -1, that is the inverse. That's arc sine. That's the inverse of the function, and that changes. That switches the input and the output. Whereas here, for the last one, we have theta to the power of -1, and that is 1 divided by theta. And so you have to be really, really careful with those negative exponents. But regardless, if we're going to do sine to the power of -1, So that's the reciprocal of sine. That's the reciprocal of that ratio. What we end up with is 1 over sine of theta equals hypotenuse over opposite, right? And so if you're trying to solve a right triangle and you need the hypotenuse and you have the opposite side, you could use sine, but we're going to introduce a new function that is 1 over sine, and it's called the reciprocal function. It's called cosecant. And so cosecant is the same exact thing as 1 over sine. It's all flipped over. So here's the relationship. We have sine, we have cosecant. Cosecant is the reciprocal of sine. Sine and cosecant are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. I think one of the most difficult things to remember is that the reciprocal of sine is actually cosecant. And I think it's kind of tricky because we remember sine and then cosine and then tangent. But here, with the reciprocals, we start off with the cosecant and then secant. They're reciprocated there. You see, they're flipped around. Anyway, do you see how this is potentially useful? If you had a right triangle and you wanted to solve for the hypotenuse, and you either knew the adjacent or the opposite side, and you want to solve for the hypotenuse, you could start off by using secant or cosecant, depending on if you had opposite or adjacent. And if you were solving for the adjacent side and you knew the opposite side, well, then cotangent would be better. Now, you don't always use these. It depends on your situation. So let's see an example. Let's say we're going to solve for the side A as well as the side C. Now, this is actually a 30, 60, 90 right triangle, so we could figure this out without using trigonometry and trig functions. But let's go ahead and use the trig here, right? So if we did the secant of 30, well, that would give us the hypotenuse over the adjacent. Secant is reciprocal to cosine. Cosine is adjacent over hypotenuse. So we flip that over. Our unknown is in the numerator. Life's a lot easier, right? So to solve this, it's just one step. You multiply both sides by 14, and you're done. Now, there are some calculator issues with this. A lot of calculators do not have a secant, cosecant, or cotangent operation. And so on paper, this is what you do. And when you use your calculator, if you can't use secant, what you end up doing is you do 14 divided by the cosine of 30. Plug it in, you're going to get 16.16. And that's how long that side would be. 16.16 centimeters. Now, let's go ahead and solve for A. For A, I would use our 30-degree angle because remember, most of the time you want to use the information provided in order to solve for something that's unknown, because it's so easy to make a simple mistake. And if you made a mistake and you got this angle up here, it's 60, but 60 and 30 is easy. But if you made a mistake, then everything you're going to do after that is wrong. So it's best to use what you've been provided with. So tangent is opposite over adjacent. And so the tangent of 30 is going to be A divided by 14. So you just multiply both sides by 14 and you're done. That turns out to be 8.08. And that is what we expected because this is the short side of a 30, 60, 90 right triangle. And it should be half of the hypotenuse. We found that the hypotenuse is 16.16. Short side is 8.08. So there's an example of how sometimes you would want to use a reciprocal function, how you can plug it into the calculator if your calculator doesn't have reciprocal functions. And sometimes you wouldn't want to use a reciprocal function. If you use cotangent here, it would be much trickier. All right, so let's see one more example. I'd suggest if you're watching this at home, you pause the video, you try this on your own, just to get a little practice, right? So go ahead and do that. Pause it right now, see how it goes. All right, now, what we're going to do is I'm going to walk you through finding the side C using both the regular trigonometric function and the reciprocal function, because what I'm hoping you see is that in this case, for finding the hypotenuse, the reciprocal function has far fewer steps. So sine is opposite over hypotenuse, right? So the sine of 37 degrees is going to be 18.4 divided by c. That's what we have right here. So to solve this, you have to multiply by c, and then you have to divide by 37. You'd plug that into a calculator. It's going to be a decimal. I'm sure if you can get this far, the calculator is not going to be an issue. Now, if we were going to use the reciprocal function, though, we start off with hypotenuse over opposite. So the cosecant of 37 degrees is going to be the hypotenuse over the opposite side, We know the opposite side. We don't know the hypotenuse. And so this is going to be a one-step deal right here. Multiply both sides by 18.4, and boom, you're done. Pretty quick, pretty easy. If you were going to solve for A, well, what we have for A is we have an angle, we have the opposite, we have the adjacent. You would use, the quickest way would be using cotangent. It would be the cotangent of 37 degrees is equal to A divided by 18.4, and boom, you're done. Now, let's see. Could you write a problem or write a triangle that would be easiest to solve using reciprocal trigonometric functions? Why don't you try it? See what you can do. Let's go ahead and summarize this video up, what we've learned, and make sure we got a good solid understanding of all the aspects at play here, right? So the first question is it easier to use the reciprocal functions when? It is easier to use the reciprocal functions when. And then the second one is the name of the reciprocal function of sine is, and then the name of the reciprocal function of cosine, you got to know that. And then the difference between tangent and cotangent is. So take a minute, think about those questions. Do you know? Here's what we got. It's easier to use the reciprocal function when the thing you need to find out, the thing you need to solve for, ends up being in the denominator. So if you're going to use sine and you need to solve for the hypotenuse, well, it'd be a lot easier to use the reciprocal of sine, cosecant. Whereas if you're going to use tangent to find the adjacent side, it would be a lot easier to use cotangent. The name of the reciprocal function of sine is cosecant. Secant is a reciprocal of sine, and the difference between cotangent and tangent is their reciprocals. The inputs are still the same, but for tangent, we have opposite over adjacent. For cotangent, we have adjacent over opposite. Hey, I hope this video has been helpful. If it has, give it a thumbs up, subscribe, share it on social media. Give me a comment down below if you found it to be helpful. If you have more questions, hey, leave a comment down below. I'd love to hear from you. There are some practice problems right here. You can give them a shot, help you, compress all your learning so that you have this moving forward. I will put a link in the description below where you can access some notes, this video, a PowerPoint, a lesson, all kinds of other stuff for trig. It's at my website, thebeardedmathman.com. I hope to see you there. Hey, have a great day.